Okay, in this video we are going to look at exponential functions grade 12 or exponential graphs grade 12. Okay, this is part 4 of 6. Okay, so we are going to look at exponential functions grade 12. Okay, we start with how to tell that an equation is an exponential equation. Okay, sometimes students confuse between this one and this one. How can you tell between the two which one is an exponential equation? How can you tell? This one is an exponential equation and this one is not an exponential equation. So how can you differentiate between the two? How can you tell? You can see in this one, which is an exponential equation, you have the variable written as the exponent. Okay, you have the variable. The variable is x. You have it written as what? As the exponent. Okay, even the word itself is explanatory. You can see you have exponential, and in the word you have exponent. Exponent. So you look for the variable written as the exponent. The variable is x in this case. You have it written as the exponent. When you have it written as the exponent, you know that this is what? This is an exponential equation. In this one, you have the number is written as what? As the exponent. Okay, so this is not an exponential equation. Okay, how many asymptotes an exponential function has? An exponential graph has got one asymptote, which is a horizontal asymptote. Okay, an exponential function has got one asymptote only, which is a horizontal asymptote. Okay, so we carry on with our lesson. Now we are going to look at the standard equation of an exponential function. Okay, the standard equation of an exponential function. When we talk about the standard equation of an exponential function, this is what you have to expect. This one. Okay, we are going to look at the letters A, B, P, and Q. We are going to look at these letters. Okay, the letter Q is going to give you the horizontal asymptote. So if you want to get the equation of the horizontal asymptote, it's going to be y is equal to q, whatever you have there. So whether it is plus 1 or minus 1 or plus 5, y is equal to that value. This is the equation of the horizontal asymptote. And if q is equal to 0, as in this case, you can see there is no q. So q is equal to 0. If q is equal to 0, then you have y is equal to 0. This is now the equation of the horizontal asymptote. Okay, when y is equal to 0, this is actually the x-axis. Okay, the line y is equal to 0 is actually the x-axis. So when y is equal to 0, when q is 0, now you have the x-axis, which is acting as what? As the horizontal asymptote. Okay, this is going to make sense as we move along. And the value of q can also give you the vertical translation, the vertical shift. This is a translation which is happening along the y-axis. Okay, so if q is greater than 0, that means q is positive, then the graph has shifted q units upward. When q is positive, the graph has shifted q units upward. Okay, if q is less than 0, that means q is negative. The graph has shifted q units downward. When q is positive, upward. When q is negative, downward. Okay, so this is a vertical translation. This is a translation which is happening along the y-axis, right? This is a vertical shift. Okay, we move on. Now the value of p. Let's look at the value of p. The value of p is going to give you the horizontal translation or the horizontal shift. This is a translation happening along the x-axis. Okay, this is a translation happening along the x-axis. Okay, so when p is greater than 0, this means p is positive, right? If p is positive, it means you have a plus there. If p is positive, then the graph has shifted p units to the left. Okay, remember that. When it is positive, to the left. Remember, positive is always associated with right. But in this case, when you have positive there, you do the opposite. You shift to the left. So positive with left when you have positive day. And if P is less than 0, that means P is negative, then the graph has shifted P unit to the right. You can see again, when you have negative, you shift to the right. Remember again, negative is always associated with left. But in this case, you do the opposite. When you have negative day, you shift to the right. Okay? Please remember that. Now, let's look at the value of A. What does A do to the graph? Okay? A, the value of A is going to tell you if the exponential graph is above or below the horizontal asymptote. Remember, an exponential function has got one asymptote, which is a horizontal asymptote. Okay? So the value of A is going to tell you if the exponential graph is above or below the horizontal asymptote. Okay? So if A is greater than 0, right? That means A is positive. Then you have the graph lies above the horizontal asymptote. When A is greater than 0, that means A is positive. The exponential graph lies above the horizontal asymptote. If A is less than 0, that means A is negative. The graph lies below the horizontal asymptote. Okay? Now the letter B, let's call it the base. Okay? We call it the base for now. So you have B to the power of X. Let's call it the base. Okay? We are going to find out. Okay? We shall find out about the properties of B. For now, let's call it the base. Okay? So let's move on. So we carry on with our lesson. Now, how to tell if an exponential graph is an increasing graph or a decreasing graph. Okay, how to tell that an exponential graph is increasing or decreasing. How can you tell if you are given an equation, if you are given an exponential equation? Okay, we are going to see that. So this is the standard equation. Y is equal to this. Okay, when you have this standard equation from the letter B, if B is greater than 1, then the graph is an increasing graph, but this is not final. But it can change to a decreasing graph if A is negative. Okay? If B is greater than 1, you have an increasing graph, but it can change to a decreasing graph if A is negative. Okay? This is going to make sense as we move along. Okay? Or if the value of B is in between 0 and 1. If the value of B is in between 0 and 1, then you have the graph is a decreasing graph, but this is not final. You have to check for the value of A, okay? But this can change to an increasing graph if A is negative, okay? From decreasing to increasing if A is negative, okay? So make sure you check for the value of A. Whenever A is negative, this is going to change. If A is positive, this is not going to change. It can only change if A is negative. Okay, now how to properly sketch an exponential graph? How can you sketch an exponential graph the right way? To sketch an exponential graph, always get the following 3 things and sketch the graph. If you get these 3 things, you will never go wrong. Okay, what are the 3 things? The first one is to get a horizontal asymptote. So an exponential graph will always have a horizontal asymptote. And the second one is to get the y-intercept. An exponential graph will always have what? A y-intercept. Always. Okay, so I'm going to have always exist. Okay, an exponential graph will always have a y-intercept. Okay, so I have always exist. And it will always have what? A horizontal asymptote. And the third thing is to get a random point. Okay, so these are the 3 things that you have to get before you can start sketching an exponential graph. Okay, if you get these 3 things, you will never go wrong. And a random point is not a y-intercept. Okay, so you get a different point which is not the y-intercept. Okay, now let's start with example number 1. Okay, we start with exponential function example number 1. this is the question. Sketch the graph of the following given equation. Okay, you are given this equation and you have to sketch the graph. So solution, if you want to sketch an exponential graph, always get the three things. Okay, to sketch the exponential graph, always get these three things. What are these three things? The first thing is to get the horizontal asymptote. Okay, the horizontal asymptote in this example is y is equal to the value you have there. Y is equal to -1. This is the equation of the horizontal asymptote. Okay, after getting the horizontal asymptote, now you can get what? The y-intercept. Okay, let me draw a line here. Now, to get the y-intercept, you let x equal to 0. Okay, y is equal to, this is the equation, negative, in bracket you have 1 over 2 to the power of x. So you let x equal to 0, right? To the power of 0, and then minus 1. And so y is equal to, you have minus, this is 1. Anything to the power of 0 is 1. So you have minus 1 and minus 1. This is minus 2. Okay, so the y-intercept is at y is equal to -2. Okay, and you need a random point. Okay, to get a random point, you are going to use any value. You can use 1 or 2 or 3, any value. So in this video, I'm going to use -2. Let me see -2. When x is -2, what is y equal to? When I plug -2 there, I'm going to have y is going to be equal to -5. Okay, you can check that. When x is -2, y is -5. Okay, you plug -2 there, and then you are going to see that y is equal to -5. Okay, you can also use another point. So now we have a random point. We have all the three things we need. We have a horizontal asymptote, a y-intercept, and a random point. Now we can sketch the graph. So this is the Cartesian plane. You have your x-axis and you have your y-axis. Okay, and you have your horizontal asymptote at y is equal to -1. There's -1 there. So you have a horizontal asymptote at -1 there. Okay, like this. This is the horizontal asymptote. And you have your y-intercept at -2. There's -2 there. So the y-intercept is at -2 there. Okay, and you have a random point, right? -2 and -5. -2 on x and -5 on y. So you have -2 there, -5 there, right? So it's -2 and -5. Okay, there, this is the point. Remember, this is the x coordinate and this is the y coordinate. Always the first coordinate is your x and the second coordinate is your y. Okay, so you have these 2 points. Now, after getting these three things on the Cartesian plane, you can now have an idea of how the graph is going to look. So it's going to be like this. You make sure you don't cross the horizontal asymptote. Okay, so it's going to be like this. So the coordinate of this point is -2 and -5. Okay, the coordinate of this point. Okay, you can join the 2 points and make sure you don't cross the horizontal asymptote. So it's going to be like this. Okay, like that. You can see you join the 2 points and you don't cross the horizontal asymptote. Okay, let's move on to example number 2. Now, example number 2, so you have exponential function, example number 2. Sketch the graph of the following given equation. You have y is equal to 4 to the power of x minus 2. Okay, solution. So, as always, to sketch an exponential graph or to sketch an exponential function, always get these three things. Okay, you need a horizontal asymptote. The horizontal asymptote, the equation of the horizontal asymptote is y is equal to the value you have there, the value of q. So y is equal to -2. This is the equation of the horizontal asymptote. And you need a y-intercept. To get the y-intercept, you let x equal to 0. Okay, so you have y is equal to 4 to the power of x. So you let x equal to 0. So to the power of 0 minus 2. Okay, so y is equal to, this is 1. So you have 1 minus 2. This is minus 1. Okay, so the y-intercept is at y is equal to -1. Okay, and you need a random point. Okay, you can use any x value. You can use 1, 2, -1, -2, any value. Plug it in there and you are going to find the y coordinate. Okay, I'm going to use 1 in this video. So when x is equal to 1, what is y equal to? If I plug 1 there, I'm going to have 4 to the power of 1. This is 4. 4 minus 2 is 2. Okay, so the y coordinate is 2. Okay, when x is equal to 1, y is equal to 2. Okay, this is a random point. Now I can use these three things to sketch my exponential function or my exponential graph. Okay, these are the three things that you always have to get whenever you are trying to sketch an exponential function. Okay, so this is the Cartesian plane. You have your x-axis and you have your y-axis. Okay, the horizontal asymptote is at y is equal to -2. There's -2, so you have your horizontal asymptote there at -2. Okay, and the y-intercept at -1. There's -1, so you have your y-intercept there. Okay, and you have a random point 1 and 2. There's 1 and 2. Okay, 1 and 2. Now you can see the graph is going to be like this. Okay, you make sure you don't cross the horizontal asymptote, so it's going to be like this. Okay, and the coordinate of this point are 1 and 2. You can see 1 and 2. Okay, now you can join the 2 points. It's going to be like this. Okay, I hope you can see that. Now example number 3. Okay, so you have exponential function example number 3. Okay, we have two questions. Question 1, use the following exponential equation and say whether the exponential graph is an increasing or a decreasing graph. Okay, this is the equation that you are given. Question 2, and sketch the exponential graph. Okay, so you have two questions here. Okay, so solution. Question 1, you may be tempted to think that b is equal to 3. When b is greater than 1, then you know that the graph is an increasing graph and you have to check for what is the value of a. From there, you are going to decide if the graph is an increasing or a decreasing graph. But before that, there is something that you have to do. You have to rearrange this equation so that you can see whether b is 3 or not 3. Okay, you have to look for this. The coefficient of x is -1. You want to have the coefficient of x +1, not -1. Okay, so we are going to rearrange this equation. Okay, so you are given y is equal to this. Okay, so this is equal to, you have 3 to the power of -x plus 3. Okay, so I take -x, there is +3 there, right? +3, -x plus 3. I'm not changing anything. I'm just trying to rearrange this equation. This is equal to 3 to the power of, you have to factorize -1 outside of the bracket. Okay, so you have -1 outside of the bracket, and in bracket you have x minus 3. Okay, I'm not changing anything. So I have factorized -1 outside of the bracket. You can see this is -x, right? You have -x, and this is +3. Okay, you have +3 there. So I'm not changing anything. I'm just trying to rearrange this equation so that I can see what is the value of b. This is equal to, now you have 3 to the power of -1, right? 3 to the power of -1. And you can write this as 1 over 3, right? 3 to the power of -1 is 1 over 3. So now you remain with x minus 3 to the exponent. You have x minus 3. Okay, so this is how you have to rearrange the equation. Now you can see the coefficient of x is a +1. There is an invisible one in front of x. This is how you want to rearrange the equation so that you can see clearly. Okay, now from this you can see that b is equal to 1 over 3, right? This is b. b is equal to 1 over 3, and a is equal to 1. There is an invisible 1 there. A is equal to 1. So now from b and a, we can now tell if the graph is an increasing or a decreasing. Okay, so when b, the value of b is in between 0 and 1, right? This is between 0 and 1. This is 0.33, and you can see it is in between 0 and 1. Okay, if the value of b is in between 0 and 1, then the graph is a decreasing graph. Okay, but this is not final. You have to check for the value of a. You can see a is 1, so a is positive. Okay, so a is positive, so there is no change. There can only be a change if a is negative. So a is positive, no change. So you are going to end up with decreasing. You can see from decreasing to decreasing because there is no change. It can change from decreasing to increasing if A is negative. Since A is positive, no change. So it remains decreasing graph. Okay, so this is how you have to tell. You use the value of B and the value of A in order to tell if an exponential graph is an increasing or a decreasing graph. Okay, now question 2. Question 2 is to sketch the exponential graph. Okay, so to sketch the exponential graph, always get these three things. Okay, remember from the previous examples, you have to get a horizontal asymptote, right? The equation of the horizontal asymptote in this example, you can see it is y is equal to the value of q. Q is equal to 0. You can see there is no q. Q is equal to 0. Okay, so the equation of the horizontal asymptote is y is equal to 0. The line y is equal to 0 is actually the x-axis. Okay, the line y is equal to 0 is actually the x-axis. Okay, after getting the equation of the horizontal asymptote, now you can get the y-intercept. To get the y-intercept, you let x equal to 0. Okay, so the y-intercept is y is equal to 3 to the power of 3 minus x. So you let x equal to 0. So it's minus 0. Okay. And so this is equal to 3 to the power of 3. Right? This is equal to 27. Right? You can see 3 minus 0 is 3. 3 to the power of 3 is 27. So this is your y-intercept. And you also need a random point. Okay? To get a random point, you are going to use any x value. You can use 1, 2, -1 or -2, any to get the random point. I'm going to use 1. Okay, so when x is 1, what is y equal to? Okay, so if I plug 1 there, I'm going to have 3 to the power of 3 minus 1. So this is 2. So this is 3 to the power of 2 and it is equal to 9. So the y coordinate is 9. Okay, so this is my random point. Now let's sketch the graph. This is the Cartesian plane. This is the x-axis and this is the y-axis. Okay, you have the horizontal asymptote, which is the x-axis. This is the horizontal asymptote, which is the x-axis. The x-axis is acting as what? As the horizontal asymptote. Okay, and the y-intercept at 27. There's the y-intercept 27 there, right? And you have a random point 1 and 9. 1 and 9. So it is there. Okay, so the coordinate of this point are 1 and 9. Now you can see the graph is going to be like this. You make sure you don't cross the horizontal asymptote. This is the horizontal asymptote. Okay, you are going to join these 2 points. Make sure you don't cross the horizontal asymptote. Okay, so this is going to be like this. And you can see the answer to question 1 was decreasing graph. Okay, decreasing graph. You can see this is a decreasing graph. Okay, let's move on.